Hi there. Today on Math Antics, we're starting a new subject where we're going to learn the basics of a special kind of math called geometry. Geometry is the study of things like lines, shapes, angles, distances, and things like that. In this video, we're going to focus on three of the most basic elements or parts of geometry. They are points, lines, and planes. All right, we're going to start with points because they're about the simplest thing you can imagine in geometry. What's a point? Well, let me draw some for you. So these are points. They're just little tiny dots in space, but they do a really important job in geometry. They help us describe specific locations in space, like the end of a line, or the corner of a square, or the center of a circle. But they won't really help that much unless we name them, because if I say, hey, look at that point over there, it's kind of hard to tell which one I'm talking about. I mean, they all look the same. So what name should we give these points? Well, let's see. How about Archimedes and Beauregard? That'd be good. Maybe Charlemagne? How about Daphne and Einstein? Let's see. Fred and Guinevere, Hiawatha, and Icarus. Perfect. You know, on second thought, those names are kind of long and complicated. Why don't we just use the first letters of each name instead? There. Now if I say, look at point A, or look at point B, you know exactly what I'm talking about. In fact, let's do that. Let's just talk about point A and point B for a minute. If you start at point A and go to point B taking the shortest distance possible, you would have gone in a straight line. A line is the next most basic element of geometry. We name a line by the points that it goes through. For example, we would call this line AB because its endpoints, where it starts and stops, are points A and B. But technically, this isn't really a line. It's a line segment. What's the difference, you ask? That's a good question. A line segment has a beginning and an end. It starts at one point in space and it ends at another. A line, on the other hand, just keeps on going in either direction forever, just like the number line keeps on going forever. Well, at least we imagine that it goes on forever. We can't actually draw a line that goes on forever, so here's what we do instead. To draw a line instead of a line segment, you just go past the endpoints a little bit, and you put an arrow on both ends of the line to show that it keeps on going. So this is line segment AB, and this is line CD. Now there's one more special type of line that we need to talk about, and it's basically a combination of a line segment and a line. We call it a ray. Rays have beginning points, but no ending points. They just keep on going forever, but only in one direction. So we only put an arrow on the end that keeps going. There. We call this one ray EF. In geometry, each of these three types of lines has a shorthand way of writing it. Instead of writing line segment AB, you can just write AB with a line over the top. And instead of writing line CD, you can write CD with a double arrow line over them, like this. And finally, instead of writing ray EF, you can just write EF with a single arrow line over them, like so.
Today we're going to learn about angles. In our last video, we learned about points and lines, and that's good because we're going to need lines to make angles. So let's start with a couple of lines that are in the same plane. We're only going to be dealing with two-dimensional geometry in this video. These lines are conveniently called line AB and line CD. Now the important thing to notice about these two lines is that they're pointing in exactly the same direction. So even if we extend them forever, they would never cross or even get closer together. When two lines are arranged like this, we call them parallel. Now you've probably heard the term parallel before, like parallel parking or a parallel universe or parallel bars. Okay, so parallel lines are lines that will never cross, even if they go on forever. But what if I take one of our lines and give it a little nudge? Now the lines aren't parallel anymore. In fact, they cross at this point right here. Let's name it point P. When lines cross at a point like this, we say that they intersect, and we call the point an intersection. And when lines intersect, they form angles. You can think of the angles as the spaces or shapes that are formed between the intersecting lines. These intersecting lines form four angles. 1, 2, 3, 4. But instead of calling them angle 1, 2, 3, and 4, in geometry, we name them by the points used to make them. For example, this angle here can be called angle DPB because if you trace along those points, like connect the dots, they outline that angle. And this angle here, we can call that angle APD because connecting those dots forms that angle. Now when naming angles, there's a nice shorthand that we can use. Instead of writing the word angle over and over again, we can just use the angle symbol instead, which looks like this. But there's an even simpler way to name angles. To learn that way, let's erase all the points and letters on our lines except for the intersection point and this one point here. Now let's imagine that the line segment between these 2 points can rotate around the point of intersection just like a clock hand rotates around the center of a clock. Let's also imagine that as we rotate the line segment, the point out at the end leaves a trail, like if a pencil was attached to it. The trail, or path, that's left when we rotate the line segment all the way around forms a circle. But if we only go part way around, then it forms part of a circle that we call an arc. This arc can represent the angle that's formed when we rotate the segment from one position to another, like from this line to that line. And now, if we shrink down that arc so that it's close to the intersection point, and then put a letter by it, like the letter A, we have another way of showing an angle, angle A. And we can do this with any angle. So the angle up here, we can also draw an arc and call it angle B. So whenever you see a letter next to a little arc like this, it means that it's the name of the angle formed by that arc. Alright then, so now we have a diagram that shows angle A and angle B. And you might notice that those angles aren't the same size. B seems to be bigger than A. But what if we rotate one of our lines until the angles do look like they're the same size? Now our angles look kind of like a plus sign. Lines arranged like this are called perpendicular. Perpendicular lines are lines that form square corners when they intersect. And these square corner angles have a special name in geometry because they're really important. We call them right angles. There's even a special symbol that we use to show when an angle is a right angle. Because they form square corners, we use a little square instead of the arc that we use for the other angles. So whenever you see this symbol, you know that the angle you're looking at is a right angle, and that the lines that form it are perpendicular. Okay, now that you know what a right angle is, let's look at a simple one that's made from just 2 rays. What will happen if we take the ray pointing up and rotate it like the hand of a clock a little bit to the right, a little bit clockwise? Well, we don't have a right angle anymore because the rays are no longer perpendicular. Instead, we have an angle that's smaller or less than a right angle. Angles that are less than right angles are called acute angles. On the other hand, if we rotated our ray to the left instead of the right, we would get an angle that's bigger or greater than a right angle. Angles that are greater than right angles are called obtuse angles. So there are 3 main kinds of angles that you need to know about: right angles, acute angles, and obtuse angles. Well, actually, there's one more type of angle that's pretty important, but it's kind of a strange one. It's called a straight angle. A straight angle is just what we get when we rotate our rays so that they point in exactly opposite directions. The result looks just like a straight line, which is why it's called a straight angle. Alright then, there's just a few more important geometry terms that we need to learn in this video. Let's look at our simple right angle again that's made from 2 rays. But this time, let's draw a third ray that cuts that right angle into 2 smaller parts. Now because the angle that we divided up was a right angle, we know that the 2 smaller angles combine to form a right angle. And in geometry, any 2 angles that combine to form a right angle are called complementary angles. And we can do the same thing with a straight angle. If we take a straight angle made from 2 rays and divide it with a third ray, 2 new smaller angles are formed. And those 2 angles combine to form a straight angle. We call these angles supplementary angles. So complementary angles combine to form a right angle, and supplementary angles combine to form a straight angle. Alright, that's all we're going to learn about angles in this video. And if you're new to geometry, it might seem like a lot. So let's do a quick review of all the new geometry words we've learned. Lines that point in exactly the same direction will never cross and are called parallel lines. When lines do cross, they cross at a point called an intersection. Lines that intersect form angles. You can think of angles as the spaces between the lines. Angles can be named by the points that form them, just like connect the dots. An arc is a part of a circle. Arcs can be used to represent an angle between two intersecting lines. When intersecting lines form all exactly equal angles, the lines are perpendicular. Perpendicular lines form right angles. Right angles are square corners, and we use a special square symbol to show that an angle is a right angle. An angle that's smaller or less than a right angle is called an acute angle. An angle that's bigger or greater than a right angle is called an obtuse angle. A straight angle is formed by two rays pointing in exactly opposite directions. A straight angle is really just a straight line. Two angles that combine to form a right angle are called complementary angles. Two angles that combine to form a straight angle are called supplementary angles. We learned some important things about angles. One of the things we learned was that angles come in different sizes. Some are big and some are small. Well, in this video, we're going to learn how we can tell exactly how big or small an angle is. We're going to learn how angles are measured. You probably already know a lot about measurement, like how you measure how long something is with a ruler or a tape measure. And the units you would use would be inches or centimeters or something like that, right? But when it comes to angles, we can't use a ruler to measure them or use units like centimeters. And that's because angles aren't about length. Angles are about rotation. And to measure how much something is rotated, we use a special unit called degrees. Now hold on a second. I thought degrees were used to measure how hot or cold something is. You know, like, it's 100 degrees outside today. Now that is a good point, you smart-looking fella. The word degree is used for a lot of different things, so it can be a little confusing sometimes. It makes more sense if you just think of a degree as a small amount of something. For temperature, a degree is a small amount of heat. But for angles, a degree is a small amount of rotation. And there's a special math symbol for degrees that we use instead of writing the word degrees over and over again. It's this little circle that you put after the number and up near the top. To see how we use degrees to measure angles, let's get two rays that point in exactly the same direction. Then let's put one ray directly on top of the other one so it looks like there's only one ray there, even though there's really two. Now let's take the ray on top and rotate it just a tiny amount counterclockwise. This point on the ray will be our axis or center of rotation. It's just like the point at the center of a clock that stays stationary while the hands rotate around it. Our rays now form an angle that measures 1 degree. And as you can see, 1 degree is a really small angle. We need to zoom in on it to see that it really is an angle. In fact, you might wonder if there could be any angles smaller than 1 degree. Yep, there sure are. And we saw one just a second ago. Before we rotated our top ray, when our rays were exactly on top of each other, that was a 0 degree angle. And there's a whole range of tiny fraction angles in between 0 and 1 degree. But we aren't going to learn about them in this video. Instead, we're going to keep on rotating our top ray and watch the angle get bigger and bigger. This special readout here will tell us how many degrees our angle measures. Now let's start out slow. 1 degree, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now let's hold it there for a second. So this is what 10 degrees looks like. 10 degrees? That's freezing! Huh. Guess you're not as smart as I thought after all. So we can see that a 10 degree angle is still a very small angle. So let's keep going, but a little bit faster this time. All right, that's 15 degrees, 20, 25, 30, 35, 40, and 45. Now 45 degrees is a special angle because it's exactly half of a right angle. If we draw a right angle in the same spot, you can see that our ray cuts it into 2 equal parts. So, if 45 degrees is half of a right angle, can you guess how many degrees a right angle is? Let's keep on rotating to see if you're right. 50, 60, 70, 80, and 90. Yep, a right angle is exactly 90 degrees. And that is super important to memorize because right angles are used all the time in geometry. Okay, do you remember from our last video that all angles less than a right angle are called acute angles? So that means that all the angles we've seen so far that are between 0 and 90 degrees, like 10, 30, 45, 60, and so on, are acute angles. But if we keep on rotating our ray past 90 degrees, we'll start forming obtuse angles. because they're greater than a right angle. Ready? Here we go. 100 degrees, 110, 120, 130, 140, 150, 160, 170, and 180. Aha! Does this look familiar? Yep, it's a straight angle like we learned about in the last video. The rays point in exactly opposite directions, and the angle they form is 180 degrees. And that's also a really important angle measurement to memorize. Now before we go on, let's quickly review the important angles and regions that we've looked at so far. Our angle measurement is 0 degrees when the rays point in exactly the same direction. It's 90 degrees when they're perpendicular and form a right angle. And it's 180 degrees when they point in opposite directions and form a straight angle. In this region, between 90 and 180, we find obtuse angles. And in this region, between 0 and 90, we find acute angles. One important acute angle is 45 degrees since it's half of a right angle. All right then, let's continue rotating past 180 degrees. Our angle readout keeps getting higher, and the next important angle we come to is this one, 270 degrees. It also forms a right angle, but it points down instead of up. Let's keep going because another really important angle is just around the corner, and it's coming up right about now. We rotated our ray all the way around the axis, and now it's back to where we started. Now you might be wondering, if we're back to where we started, then why is our counter reading 360 degrees instead of 0 degrees like before? And the answer is that even though our rays are back to the same place, we had to rotate our top ray 360 degrees to get there. And you can see that our angle arc now forms a complete circle. So 360 degrees is the angle that represents a full circle. Rotating 360 degrees brings you all the way around the circle to the point that you started from. Okay, now that you know what degrees are and you've seen how they relate to the size of an angle, we need to learn how to actually measure an angle without this fancy readout that we have here. Just like a ruler can be used to measure the length of a line, a special tool called a protractor can be used to measure angles. A protractor is similar to a ruler, but it's curved into a half circle so that it can measure rotation around an axis point. A protractor also has a straight edge with a hole or a dot in the middle that represents the axis or center of rotation. So if you're given a mystery angle, like this one, and you want to measure how many degrees it is, you just put your protractor on top of it so that the axis point lines up with the intersection of your rays, like this. Then you make sure that one of the rays lines up with the straight line on the protractor. And last of all, you look to see where the other ray crosses the curved part and read off what angle measurement it lines up with. As you can see, this angle here is 50 degrees. All right, there's one more thing I want to teach you in this video because you'll probably see this kind of geometry problem on your homework or tests. Do you remember what complementary and supplementary angles are from the last video? Complementary angles combine to form a right angle, and supplementary angles combine to form a straight angle. Well, now that we know that a right angle is 90 degrees and a straight angle is 180 degrees, we can use that information to solve problems that have unknown angles, like this one. It shows two angles, angle A and angle B, that combine to form a right angle. The problem tells us that angle A is 30 degrees, and it wants us to figure out what angle B is. Fortunately, it's easy to figure that out now because we know that a right angle is 90 degrees, so we know what the total of both angles must be. That means that to find angle B, all we have to do is take the total, which is 90 degrees, and subtract angle A, which is 30 degrees. And whatever's left over will be the measurement of angle B. So 90 minus 30 equals 60. So angle B is 60 degrees. Now let's try this problem. It uses the same idea, but with the straight angle this time. The straight angle is divided into two smaller angles. Again, angle A and angle B. And again, the problem tells us that angle A is 70 degrees, and it wants us to figure out what angle B is. Well, we know that the total of both angles must be 180 degrees because we just learned that that's how big a straight angle is. So if we take that total, 180 degrees, and subtract angle A, which is 70 degrees, whatever's left over after subtracting must be angle B. So 180 minus 70 equals 110. Pretty cool, huh? And now you can see why it's important to know how degrees work in geometry. They can tell us how big angles are or how much something is rotated.